All right, so go ahead and get those journals out. Make sure that you are at your next blanks page. I'm going to have to catch mine up. Let's do it without a lot of talking, okay? Yep.
What about what we do on the...
That's what I'm working on, sweetheart. All right, so I'm at 19, page 20. I got to catch... Two. All right, I got to catch all mine up. Hang on. Make sure your number...
all the notes that you wrote when you were gone.
Boring.
I'm not going to work on the page.
Well, it's going to be a major grade, so I wouldn't do that.
Can I use the back page to write the content since I ran out of space?
How did you run out of space? Oh, okay, yeah.
I'll give you one for your example.
How, Claire?
Just while they're printing. Here's one for your
Okay,
example.
thank you.
Oh, wait, I'm so confused.
All right, I am too because y'all are still talking. All right, so we're going to do a quick review over prime and composite. So let me bounce over to my blank page. Remember that your page numbers may be different than mine, and that's okay. All right, so let's just make a note that Elise and Nathan need to make up these notes. Okay, so this should be a quick page, all right? And Michael, will you make sure everybody gets one of those, please, and thank you.
Everybody one.
All right, so I'm going to jump onto your notes real quick. Okay. Anybody still catching up, or are we good?
I'm still good now. I'm just going to...
Okay. All right, so let's go ahead and start with some definitions, like we usually do. Okay. All right, does anybody know what a prime number
You
is?
told me to call.
Okay.
Did you say
Caitlin?
A prime number is a number where you can like multiply it like more than once, like except for like one, like not only one, right?
Okay.
And a composite number is a number where you can only like multiply it by one.
Okay, would anybody else just explain that differently?
Yeah, I can explain it well.
No, I'm just asking for anybody else.
Do we write our names on these?
They're for you, yeah, if you want to. Uh-huh.
In fourth grade, Mrs. Lodge told us that prime numbers are numbers that can't be multiplied.
That can't be?
Yeah.
Okay. Anything else?
I thought it was composite.
All right. So, a prime number is a number that only has two factors.
Oh yeah, I did it backwards.
Oops, this is running out of ink.
I did.
Only has two factors, one and itself. Okay? So let me give you an example. An example of that would be like a 2, 5, 7. Okay? So when we start walking through these numbers and I think, okay, what can I multiply that would equal 2? The only numbers or factors, remember factors are numbers that we multiply. The only two numbers that will multiply to make 2 are 1 and 2. Does everybody agree? Are you with me? The factors of 2 would be 1 times 2. There are no other numbers I can multiply that equal 2. Agree or disagree?
Agree.
All right. I'm going to say the same thing about 5. If I start going down my list, I'm going to think, okay, 1 times 5, right? 2 times 2 is 4, so that doesn't work. 3 times 2 is 6, so now I'm already too big, and now I'm done. 5 is a prime number. Okay, same thing again with 7. Definitely 1 times 7, right? Same thing if I go through. 2 times 3 would be 6. 3 times 2 is also 6, right? And then that gives you 4 times 2 is 8. So at that point, it's too big. There are only 2 factors for 7. Give me a thumbs up if you're with me.
Mm-hmm.
In the middle if you're getting there. Thumbs down if you have no idea what's happening. Okay? Okay. Can anybody think of a few other numbers that are prime? Caitlin?
1. Oh, wait, no, that's none of them.
1 is not. So let's hold on to that one, though. Stone?
3.
Okay. 3 is also prime. Anybody else? What about 21? Is 21 prime?
No.
No.
Why not?
Because
Raise your hand. Yeah.
you can do 7 times something?
3.
7
7
times
times
3.
three.
Yeah. So I've got 1 times 21. 3 times 7. Right? So it's not prime. So if I only have 2 factors that will equal this number, I can only multiply 2 numbers. It's going to be 1 in itself, then it is prime. That takes us to composite numbers. Okay? Okay? So if a prime... All right, just realized we were not recording, so hopefully we haven't missed too much. Go ahead and pause if you're recording these and make sure that you have all of them down. All right, so we were just saying that if a prime number is a number that only has 2 factors, right, 1 in itself, then a composite number is what? Raise your hand if you can tell me. What is a composite number? Anybody but Caitlin. The only one who's answering anything today. Stone, what's a composite number?
A number that has
If a prime number only has 2 factors, then a composite number has what? Huh?
1.
Oh no.
5. 3.
Caitlin?
More than 2.
More than 2.
Oh.
So all of you were giving me good numbers, but we don't want to say they only have 3 factors, right? It has more than 2 factors. Examples of this would be 6, 8, 10. I mean, there's lots of them, right? But we could, these are just pretty fast, easy ones. Is everybody good?
Yes.
Should I pause for a second?
Yes.
I'm good.
Okay.
I'm good.
So with 6, we start going down our digits, right? I always just try to go in order. So I've got 1 times 6. Does 2 go into 6? It does. 2 times 3. 3 goes into 6. Now, if I already have 2 times 3, I don't need to write down 3 times 2, right? Does 4 go in it? No, because 4 times 2 is 8. So now we stop. Everybody good there? Same thing with 8. Start with 1 times 8. 2 times 4. Okay, 3 times 2 is 6. 3 times 3 is 9. So we're done. Right? And 1 times 10. 2 times 5. Then if I'm still thinking, what else can go into these? 3 times 3 is 9. 4 times 2 is 8. 4 times 3 is 12. And we're done. Does everybody understand what I'm doing there? Give me a thumbs up if you're with me. In the middle if you're getting there. And thumbs down if you have no idea. Love it. Okay. All right. Go ahead and finish writing these down.
Oh, I'm ready. The whole time you were talking, I was still ready.
Okay.
So what is the short form?
It's for me to know and for you to find out, Clarabelle. Crazy kid. Okay, so the only exception in whole numbers, like we're not going to get into anything more complicated than that in the 5th grade, right? Is 1, okay? All right, so we're just going to write here that the exception to to this rule is the number 1, okay? It's not prime. It's not composite. It's just 1. It's special. Me too. I don't know, Clara. I think you'll always be a number 2. Sorry. Okay. Should have said that. Okay. Don't kill me. Don't kill me. All right. Are everybody good here? No. So the no promises. All right. You all heard her threaten me on film. Everybody good here? Okay. Any questions about prime or composite? Nope. What I want you to do is this. Go ahead and take out or pull up this little hundreds chart. And I want to just run through it as quickly as we can with your highlighter. Now you should have more than one highlighter, okay? Better be in your binder. Now this is where we're getting into that, hey, I'm going to junior high and I switch classes every hour on the hour. So I always have my things with me that I might need. Now we haven't used highlighters in a while. But that doesn't mean that they shouldn't still be in your binder the way we set it up at the beginning of this year. They stay in there until you need them. If you don't need them, they also stay in there. Yep. Oy vey, Michael, Riney. All right, everybody got one. Let's go.
I lost all of mine.
We used them in Coach Lewis's class.
Y'all, I'm not even going to lie. I'm a little unhappy with some of y'all. You know what, Gary, go behind me right here. There should be some in that box. So super fast. Now, if you don't have your supplies, either your teacher is going to go on without you. No, to the right of the lamp. To the right of the lamp. In the middle bin. Are there not some in there? Okay, open the cabinet over there. Real quick. Look on the top. Now, either your teacher is going to wait awkwardly for you to find something, or they're going to go on without you, which is going to stress you out, okay? You got to have your stuff. Now, what I want to do is I want to go ahead and just highlight prime numbers, all right? So when we're doing this, we're going to have to kind of think through really what we just need to know is if all of these numbers are divisible by 2. How do I know if they're divisible by 2? If they are even, right? Okay, so I'm going to start with that. So I'm going to go through, and I know that 2 is prime, right? We said that 3 was prime. Is 4 prime? No, it's even, right? Is 5 prime? Yes, it can only be. All right, so I'm just going to maybe do something like this. All right. What about 6?
No.
No, it's even. All right, 7.
Yes.
Okay. Now, just because it's not even doesn't mean it's prime, right? But we have already talked about 7, so we're going to go ahead and color that in.
Wait, why can't we color?
8 is not. What about 9? 9's not even. Is it prime?
Yes, because it's 3 times
3 times 3, so we're leaving it alone. We already looked at 10. It was not prime. What about 11?
It is prime.
Okay. Yeah, 2 doesn't go in it. 3 doesn't go in it. Okay, so 12 is even, so we know for sure it doesn't work. What about 13?
Yes, it is. Right.
Okay, so yeah, we kind of think through. 2 won't go in it. 3 won't go in it. 3 times 4 is 12, right? 4 definitely doesn't work. Doesn't work with 5. So yeah, we're pretty sure that 13 is prime. Okay, you can fill yours in again. I'm just going to go around mine. 14 is even. 15. Prime or composite?
Prime.
Wait.
Composite.
It's composite.
Oh, yeah.
Now remember, it's not even, so I know 2 won't go into it, but will 3?
Yes.
3 times 5, right, is 15, so let's leave it alone. 16 is even. What about 17?
That's a prime.
Okay, so let's just think through and make sure, right? 3 times 2 is 6. 3 times 3 is 9. 3 times 5 is 15. So 3 times 6 is 18. No, doesn't go in. 4. I'm just kind of thinking through them. We're gonna leave. So yes, this one is prime. 18 is good. What about 19?
Oh, 19.
19's prime, isn't it?
Yeah.
I think so. 20's good. 21, we talked about. 22. Now, any digits that are double, like this, can be divided by what number? Think through your multiplication facts. 11, 22, 33, 44. What are those multiples of? 11. So if they're double digits like this, they're also composite because they can be multiplied by 11. 23.
Oh, that's a composite. I mean,
Okay, 3 doesn't go in, 4 doesn't go in, 5. Three times 9 is 27. I think we're good. Okay,
Yeah.
let's make it prime.
What do you think, Glitch?
Are we going?
Yep, so we're just going to go through. Now, 24, no. 25, no. 26, no. 27, no. So let's just kind of walk through it a little faster. 27, 3 times 9, right? 28, 29. Okay, so you guys get the gist, right? So, okay.
I accidentally wrote on 21.
You marked 21? Okay, well, put a...
Well, 11 would be 22. Yeah. So that's why
Yep.
I highlighted.
Well, she's saying she did highlight 321, which is 3 times 7. All right, so we definitely want to be careful here, right? Okay, so do you guys kind of get the gist of what we're doing? All right, I want you to stop for a second, and I want to talk to you about divisibility rules, and that is actually going to be the second, the top of this just, okay, there we go.
How do you scratch out highlight?
What's that?
How do you scratch out highlight?
You don't. All right, so jump back to the beginning here, okay? Just put that to the side for now. And let me see, this is going to be page 26 for me. And I want to talk to you about divisibility rules. Okay, divisibility rules. I'm going to go ahead and jump back.
Wait, can we go back to the...
Hang on one second, I'm going to put it at the top of this page, okay? Alright, so on the next page. So these are divisibility rules. Alright, and I am going to give you guys a copy of these after we write them down, okay? I have some smaller copies. Actually, I might have some bigger ones.
I know.
I know, right? I know I kind of looked at it like, did you spell that correctly, ma'am?
5 of them. 1, 2, 3, 4.
I think it's right. Okay, now, divisibility rules
It sounds like
are shortcuts that we can use when we're trying to figure out a lot of different things, like what are the factors of a number? Is a number prime or composite? After this lesson, what we'll be looking at are common factors between numbers before we jump into fractions, okay? So this is something, and I even have them up on the wall, although that needs to be refreshed. Divisibility rules are the best, okay? That's why I want to start working on them now. I want you to be able to use all of them before the end of the year because they will save you so much time, okay? And you'll use them for a long time, I promise. All right, so these are just like little shortcuts that we want to recognize about numbers to quickly or more quickly decide what numbers divide into them or what numbers multiply to make them. Are you with me? So, all right, we're going to start with number 2. And yes, I am going to give you a copy of this, but I also want you to write it. Okay? For some of you, seeing helps you learn. For some of you, writing helps you learn. But we're going to do all of them. So for any number, if I want to know if 2 will divide into it, we just talked about the fact that if it's even, 2 will go in it. Okay? If it ends in an even number, you know what? I'm even going to say even number at the end. Okay? Because you could get a number that's in the billions. But if that number ends in an even number or a 0 at the end, it will be divisible by 2. Okay? No matter how big it is. So for this, like if I had a number like 1074, but it ends in an even number, so it is divisible by 2. Everybody okay? That one's pretty easy. Okay?
I do have a question.
Yeah.
I can't really see is that a circle and a dot in the middle?
Oh, this is an at sign.
Oh.
At the end. Anybody else not familiar with that?
I did.
Like at Fellowship-Academy?
I know.
I did it the wrong way.
I know.
Oh, that's okay. As long as you know. I mean, here, we can do that.
And then is that a circle?
Yes.
Oh, or 0.
It's much better.
All right.
Zero. The 0.
Oh. I made it open.
Okay, so 2 number. Oh wait, I didn't think you did.
Alrighty. Did y'all just ay her?
No,
I
that
did.
was
Okay. All right. For number 3. Now, I can look at any number and know that it's divisible by 3 by adding the digits. And if they equal a multiple of 3, they work. Okay? So an example of that would be, do I have an example on here? Yes, 312. So if I'm looking at the number 312, what I'll do is I'll say 3 plus 1 plus 2 equals what? 3 plus 1 is 4. 6. Is 6 a multiple of 3?
yes.
Yeah.
Then 312 can be divided evenly by 3. I'm telling you, these will change your life. Some of them are simple, like the 3s and the 2s. Some of them get a little more complicated, and frankly, I don't really use all of them. The bigger the numbers, but some of them just are. I mean, most of them I think are just easier. Okay. Anybody still writing?
I am.
Okay. If you're at home, remember that you can pause and just copy this down. Okay.
I was at home.
All right. So that's 3. How are we doing so far? Thumbs up if you've got it so far. Middle. If you're getting there, thumbs down if you don't understand.
I'm sort of there.
Sort of there. Okay. All right. Let's look at the 4s. Now, keep in mind, these may not make sense to you right away. And they're not going to be something that comes easily to you until we use them on the regular. All right, so 4 is probably one of the ones I use a little less than the others. But for the number 4, you take a look at the last 2 digits. And that, how did we put that? Last 2 digits can be divided by 4. Okay. So this one is not as great as the other ones, but in a really long number, it will come in handy. that if we look at the last two digits and they can be divided by 4, then the entire number can be divided by 4. So an example of that might be like 124, right? So I look at the last two digits, and 24 is equal to 4 times what? 6, right?
Oh, yeah.
Oh, yeah. Oh, blah, blah. Okay. So, you sorry suckers are like, well, okay, Miss Fan. Okay, so if the last two digits can be divided by 4, it works, okay? Again, I think that this is going to be one that you don't use quite as often. Sometimes it's just easier to just do a little division on the side and divide 4 into it real quick, okay? But what makes no sense?
How does 24 equal 4 times 6?
Exactly.
Because
What's 4 times 6, okay?
4 times what gives me 24, Dawson?
Oh.
So again, the last, okay, because of Dawson, go ahead and girlify this last two digits. Oh, thank you, Dawson. They love to girlify. Okay, so if the last two digits, listen, Lindas, and don't talk over me, it will not go well for you. The last two digits can be divided by 4. Now imagine if this was like a 6-digit number, right? We don't want to divide 4 into that. If we can just look at the last two digits, it will help us. Okay, you comprende me? We good? Ish?
I do have a question.
Yes, question.
Okay, so so say the thing was like, oh wait, it's already 124. Okay, so it's 124, okay? And then you divide 4 times 6. Why do you do that?
No, I said that 124 is divisible by 4 if the last two digits, which are 2 and 4, can be divided by 4. So, can I divide 4 into 24 evenly?
Yeah.
Yes, because 4 times 6 equals 24.
Wait, how does that help?
So 4 divided by into 24 equals 6. Think fact families. Can I divide 4 into 24 evenly?
Yeah.
Yes, because 4 into 24 is 6, or 4 times 6 is 24. Right?
Yeah.
Okay. Yes.
I have a question. What's the
Sure.
meaning of the 2, the 3, you know, where it has a 2 and an arrow, 3 and an arrow?
Yeah.
What's the meaning of that?
This is the rule. I'm just pointing to the rule.
Oh, well, why don't you do 1?
Because 1 goes into everything. 1 times itself equals the number. I don't need a divisibility rule by 1. These are tricks. Everything is divisible by 1. Everything is divisible by 1.
One specific number, I think it's like 12 or something like that, and you can't divide it by 1.
Yeah, 1 goes into 12 times. 1 times 12 is 12. Yeah, it's the same for everything.
There's one that's like undefined, you can't do it. Yeah, you can. Undefined.
Not whole numbers. Yeah. Okay. All right. So let's hold on. Let's hold on to this for now and talk through the rest, and then we'll come back and use some of these separately. Okay. All right. So what about 5? How can I look at a number and just by looking at it know if it can be evenly divided by 5?
It has to have It has to have a 5 at the end or a 0 at the end.
The number ends in 5 or 0. That is correct. Any number, no matter how long. If it ends in a 0 or a 5, it can be evenly divided by 5. Okay?
I have another question.
So did I even... Yeah, so 15 or 50, right? Either of these numbers can be divisible by 5 because of how they end. Okay? Question, Clarabelle?
Wait, I'm right this.
Go ahead.
Okay. Why are you teaching us tricks?
Because, as I said earlier, knowing if a number is prime or composite is going to help you to figure out common factors between numbers. What we're going to do next, let me say this. What we're going to do next is we're going to learn how to add, subtract, multiply, and divide fractions. What we also need to do with all of those fractions, is reduce them, which means make them the smallest version of themselves. And these tricks are going to help you with that. And actually, it's not even a 5th grade TEK that I could find, but we're still going to start doing it because you will be responsible for it from 6th grade on. Okay? So, and it's one of the hardest things for kids to do even in high school is reduce fractions. For some of you, it's going to come really easy, but for a lot of kids, it does not. So we're going to be practicing now to start getting you ready. Yeah, Caitlin.
So, whenever we start dividing fractions, my sister learned this in 6th grade, and there was this little, like, song video thingy, in, like, I think it was Miss Henshaw's class or whatever class they did in math, and it goes like, to divide by a fraction, here's a tip, keep, change, flip.
Oh, to divide them? Yeah, we'll talk about that when we get there.
Keep, change, and flip.
Okay, but yeah, so let's hold on to that. Because, I don't have a song for it, but we will, that's how we'll be doing it as well. And Miss Henshaw is an excellent teacher. Y'all will learn way more from her than you have from me, trust me. All right, so that is the 5s. Now for 6s. The 6s are pretty simple, okay? So if that number can be divided by 2 and 3, it works, okay? But it has to follow under both rules. So did I, okay. Yeah, so I have 12, right? Twelve can be divided evenly by 2 because it ends in a 2, right? And then 1 plus 2 equals 3. And then it can be evenly divided by 6 because 6 times 2 is 12, right? Are y'all with me there? So, again though, if a number can be divided by 2 and 3, so if you look up here and they follow the rules for 2 and 3, it will also divide into 6. Okay? That's what you need to remember. 2 and 3 are really easy to check. So if I have gone through those, and we will be practicing going through writing all the factors out for numbers, and you will use these, I promise. When we do that, if the 2 and the 3 trick work, then you also write down a 6. The 6 works. Everybody good here? Yeah. Are we still writing?
No, I'm still writing.
All right, so there is an H trick, but I'm not going to give it to you. If you want to look it up later, you can, but to me, it's like multi-step. To me, some things are just easier to just divide out, but I've never used it, and I don't teach it. So if you want to look it up yourself, you can. All right.
Wait, how do we go from 6 to 2?
Oh my gosh.
Because 8 and 7 no longer exist anymore.
Wait, what?
Because I don't have a trick for 7, and the trick for 8 is trash.
What's the trick for 8?
Why did 7 trash? Wait, what's the thing is like, why did 8 eat 9 or something?
That's a joke, but I don't think it's a math trick.
Yeah,
So.
but what is it? Like, why did 8 eat 9?
Because he was hungry.
Yeah.
All right, so the rule for 9s, listen, Linda, the rule for 9s is just like the 3s. Okay, so if I add all the digits and they equal a multiple of 9, then it's divisible by 9. For example, 234. Okay. So that's 2 plus 3 plus 4. Is everybody with me? Or are we still writing?
No, I'm still writing.
All right, catch up. All right, so again, if I can take all the digits in 234, that's 2 plus 3 plus 4. That's 2 plus 3 is 5, plus 4 is 9. Then that number, 234, can be evenly divided by 9, which means 9 is a factor of that number.
Yay! And then 10.
And then 10 is super easy as well.
Beautiful. It's been like 30 minutes.
What's your problem? Clara, what's your point?
Oh. It's not take a while, so you have to watch the video. Who cares?
Should have been here then. All right. So, if a number ends in 0, it can be divided by 10 evenly. Doesn't matter how big it is. 10 will go into it and divide into it evenly. Okay? Does somebody say what's the point?
No.
No, that's great. That's ironic. That's ironical.
I just wanted to say that. Not like about the. About the thing.
What's the point? All right. Is everybody good here?
What's the point for saying what's the point?
What's the
point
point?
here, guys?
Okay. So let me stop this here and let's finish with your prime chart. Okay. Bye. I'll put a picture of the prime chart on Google Classroom. Bye.